welcome to the first in a series of technical tips from Polymer Resources. My name is Todd Hodis, Director of Marketing for Polymer Resources, and we're very excited to launch this new series. Our objective is to not only offer educational, practical, and informative content, but also bring our technical team to yours. Having multi-decade and in some cases, multi-generational team members, we bring years upon years of plastic compounding experience. What's more, Polymer Resources has been in the compounding resin business for over 46 years. And throughout almost half a century of manufacturing and supplying custom color and standard formulations, Polymer Resources has gained industry confidence as a steadfast, high-performance, and innovative supplier, always being able to follow through on customized solutions for any resin program. There's a myriad of reasons that differentiate Polymer Resources from the pack. However, surely our people make all the difference. Having said that, I'd like to introduce Henry Sorgen, Technical Development Engineer for Polymer Resources. Henry also goes by Hank. Hank provides on-site and off-site technical service, as well as plastics manufacturing consulting services, and has been in the industry spanning a multitude of roles, such as process technician, project manager, and senior manufacturing development engineer. To say the least, Hank is our injection molding guru. So now I'd like to turn it over to Hank to begin. Hank?
Thank you, Todd. I appreciate any opportunity to better help spread and share knowledge throughout the plastics industry. Good afternoon, everyone. My name is Henry Sorgen, Technical Development Engineer for Polymer Resources. Today's topic will be on material drying and adequate dryer sizing. Though drying of polymers is a fundamental process, it is a very crucial step when running engineering-grade thermoplastics. So first off, understanding why do some polymers need to be dried and some do not? The answer, hygroscopic resins. When processing hygroscopic resins, or polymers that naturally absorb moisture, such as our nylons, ABSs, PBTs, and polycarbonate products, it's very crucial to ensure proper drying of the material prior to processing of the material. In doing so, you'll help prevent hydrolysis, cosmetic defects such as splay, or part failure. It's also important to note that different resins have different moisture capacities. As most know, nylon, very hygroscopic, compared to a polyethylene, or propylene, not so much. So drying, getting the moisture out. Drying of hygroscopic resins is required to obtain and enable a repeatable, robust molding process. Running dried material also ensures maximum polymer performance as intended by the resin supplier, which means the ranges and values of data that are provided on the material data sheets for each material. The melt flow rate that is provided on specific materials is based on that of a dried polymer. Processing the resin in an undried state would cause the polymer to act as if it had a much higher melt flow rate, degradation due to hydrolysis. Melt flow rate is a direct correlation to viscosity of the polymer. The lower the melt flow rate, the higher the viscosity. Runs like mud or molasses. If it's wet or undried material, you will have a very low viscosity or a high melt flow rate. Runs like water. The number one challenge as molders while processing of plastics is maintaining viscosity. By maintaining viscosity, you can maintain a consistent and repeatable process. Hydrolysis, defined by the chemical breakdown of a compound due to the reaction with water, meaning that the molecular weight of the resin degrades due to breaking down of covalent bonds, shortening the molecular chains of the polymer. Since the polymer's properties depend on its high molecular weight, reducing that weight or shortening of the molecular chains will result in significantly reduced properties. Cosmetic defects. Splay or silver streaking are cosmetic blemishes that appear on the surface of a molded part. This defect appears most commonly when there's a form of gas, usually steam, trapped within the melt. This can also be caused by unmelts, dirt, contaminations, or excessive volatile gases from additives, which is another result of degradation. It is important to remember that resins subject to hydrolysis should not be reground and reused if they show signs of splay derived from too high of a moisture content. Reintroducing and mixing polymers that have been degraded due to hydrolysis with a virgin or non-degraded material will not produce a good representation of the material's intended properties. Please feel free to check out this embedded link for a good read on identifying and correcting splay. Part failure. If the hygroscopic resin is not dried to within an ideal level of moisture content, the negative impacts on the material's intended properties of the polymer are likely to occur. Structural defects or even premature part failure may be observed due to this. On the left, we have an example of failed snap tabs upon attempting to mate this part with its mating part. The drying process. This requires dry air, controlled dew point, temperature, and time. Most effective and common type of dryer used in industry, that's going to be the desiccant bed dehumidifying dryer. It dries air to a required dew point level, heats air to a specified temperature, and circulates airflow within its own closed loop system. Moisture then migrates out of the polymer and is removed from the circulating air via the desiccant bed. So the desiccant bed. The desiccant bed is a cartridge-type filter made up of moisture-absorbing desiccant beads. It's very crucial to ensure maintenance and proper working function of the desiccant bed. Dew point levels is just one way of monitoring the desiccant bed performance. Nominal dew point is typically around -20 degrees Fahrenheit or lower. So an example for desiccant, that's going to be silica gel desiccant beads. It's an example of a hygroscopic resin. I'm sure everyone has seen these little packets before. They can be found in everyday consumer items and packaging, shoe boxes, vitamin containers, clothing, or packaging for an array of items from electronics to foods. So as we know, moisture and condensation encourages the growth of mold and spoilage. Condensation may also damage other items like electronics and may speed up the decomposition of chemicals. When using these silica gel desiccant beads, they act like a dryer's desiccant bed in the sense of capturing unwanted moisture. When you guys get a chance, here's another embedded link for 6 ways to use these little silica gel packets. You may find some interesting uses. So schematic of a dryer. So here you can see the dryer system as a closed loop. A blower motor will force air through the desiccant bed to lower its dew point, and then through a heater to raise to the ideal set temperature. It is important to note that both of these actions to obtain target dew point and target air temperature will require time. This time is not a part of the recommended drying time that is provided by the material supplier. Once the dew point and air temps are reached, the dry air will force out the unwanted moisture within the pellets of the hopper. The now wet return air is then passed back through a filter to remove any dust or fines and back into the desiccant bed to be dried and continue this closed loop cycle. Reactivating of the desiccant beads. Just as plastic pellets become saturated, the desiccant beads can become saturated and will need to be periodically reactivated, in other terms, re-dried. On the right, we have an example of a desiccant bed cartridge filter as shown. Dryer sizing. Ensuring adequate dryer capacity is another very crucial part of the drying procedure. The dryer should be sized large enough to provide adequate resin residence time within the dryer. Properly sizing the dryer can be determined based on 2 things. Throughput, typically in units of pounds per hour, and the material supplier's recommended dryer time. Throughput can be calculated by determining total shot weight multiplied by total cycle time. So rule of thumb used to calculate dryer sizes, that is equal to throughput multiplied by dryer time. Let's do an example. So here we have an example of the Polymer Resources PCGP1. It has a recommended drying temperature of anywhere between 245 to 255 Fahrenheit. Let's call that a nominal of 250 degrees Fahrenheit. And a drying time range of 3 to 4 hours. Would be suggested to lean towards the later part of that. Drying time maximum is 8 hours. So ideally, would not want to leave that dryer on for longer than that 8-hour period. So if we're using this PCGP1, and let's say we have a 1 pound shot size and we have a 30-second cycle time, that's going to equate to 2 pounds per minute. We'll multiply that by 60, turn it into an hour. That's 120 pounds per hour. So per our data sheet, we recommend drying time of 4 hours. 120 pounds per hour multiplied by those 4 hours is equal to a 480-pound dryer. If a dryer with a capacity of less than 480 pounds was used in this instance, there would be a high potential to outrun the dryer and eventually allow material into the system that exceeds the appropriate moisture content. Overdrying. This can also be looked at in the opposite manner. What if you have a dryer that is too large for the job? Having a dryer too large would enable the possibility for material to dry for a time much greater than our recommended drying time, which can potentially lead to a form of thermal degradation. Again, that would result in reduced mechanical properties. If polymers are over-dried, they need to be allowed to reabsorb their moisture up to their equilibrium point. So then they can be dried again. The cycle of polymers being dried and then allowing to reabsorb moisture just to be dried again can take place more or less for an infinite amount of cycles. In some cases, polymers can be dried beyond repair, meaning that thermal degradation has occurred to the level at which components within the compounded formulation have degraded away. So suggestions to avoid moisture-related issues. First, let's ensure that dryers are working as intended. Proper drying temperatures and times are being used and not exceeded. You can also use timers to turn on and turn off dryers to prevent over drying. These timers can also be used to turn on dryers in the early morning to save time prior to starting the shift. Another option, ensure proper sizing of dryer. Don't want to outrun the dryer capacity or be using a dryer that is overkill in size. Another one, ensure proper dew point and inlet temperatures going into the dryer and hopper. Make sure that you're actually set where you need to be set. Another is make sure desiccant beds are being reactivated and functioning properly. If you're using regrind, in some cases, you may want to increase drying time by roughly 1 to 2 hours due to the larger pellet size and pending if that regrind is being reintroduced directly back into the system after molding and being reground, or if that scrap and regrind has been sitting around for days or weeks and has reabsorbed moisture back to its equilibrium. And lastly, confirm and note moisture content levels of dried material prior to processing with use of a moisture analyzer. For most accurate results, it's recommended to use moisture-specific method instead of the weight loss method if possible. On the depiction on the left, we have an example of running a PBT where the recommended drying temp is 250 degrees for 2 to 4 hours. You can see on these curves, there's a difference between 30 degrees drying temperature. One is at 250, the target ideal time, and one is a little lower at 220. You can see the impact on hours to reach the desired moisture content that just a simple 30 degrees change has. Moisture analyzer types. Mainly two types. We have moisture-specific method. This takes volatiles removals into account during the moisture analyzing. These are more expensive, yet they are definitely more accurate because they take into account those volatiles coming off. The weight loss method, however, does not take into account the volatiles being removed. They are less expensive and yet less accurate. If you guys get a chance, it's a good read here for everybody to get in and read the importance of moisture analyzing and the difference between analyzer types. One of the first things that I've always liked to ask when I'm running or attending a sampling is, what is the moisture content? Knowing that prior to starting will help you prevent a lot of scrap.
Great. Well, thank you, Hank. Awesome information. Let's now discuss some frequently asked questions that you oftentimes come across on shop floors. Let's start with the top here. What are some of the hazards/challenges one can face if hydroscopic materials are not dried properly?
I'd say probably one of the biggest one is going to be inconsistency in your processing due to that wet material. That's going to make a greater chance for potential for degradation of the polymer and being too wet or too dried for that matter.
Excellent. What is the most effective type of dryer?
That would be a desiccant bed dehumidifying dryer.
What are the three most important variables of the drying process?
That's a simple one. That answer would be dew point, temperature,
Great.
and time.
And what is the most accurate?
Most accurate type of the moisture analyzer is going to be the moisture specific analyzer.
Excellent. Where does one find material supplier info regarding drying?
This information can be found on the materials data sheet, the drying times, drying temperatures, and the recommended maximum moisture content.
Where does one find moisture programs for specific materials?
That's a really good question. More than times than one, I've not been able to locate an exact ideal program within the moisture analyzer. If you ever run into this, you can contact the manufacturer of the moisture analyzer being used. If that file is not available from them, a file or program can be created. Now, this is going to require about 2 pounds of resin, the technical data sheet, safety data sheet for the material, the generic material description, any percentage of fillers, the types, any flame retardants, impacts, or lube additives, and you can expect about a 2-week turnaround to receive that program.
Excellent. And what is the recommended dryer dew point?
Recommended dew points typically around -20 Fahrenheit, anywhere up down to further -40 degrees Fahrenheit.
And what is a common maintenance item on a dryer?
I'd say most common maintenance items are going to be your conveying air filters and then the desiccant beds itself. If it's not a regenerating bed, that is, sometimes these beds can last anywhere to 6 to 10 year lifespan. It depends on how much the dryer is being used.
Great. And why is processing impacted due to running wet material?
Well, you're virtually boiling off the water and putting steam into the barrel. Putting those bubbles in the melt can potentially give you some troubles down that road.
What are common visual defects caused by moisture/wet resin?
I'd say your most common visual one is going to be splay, or also known as silver streak.
And what can be impacted due to hydrolysis degradation?
Many things: melt viscosity, molecular weight, mechanical strength, all these items.
And lastly, what are 4 main factors of drying?
That's an easy one. That's going to be drying temperature, dew point, residence time, and the amount of airflow. So, as everybody knows, drying is very important, and getting that moisture content level prior to going into processing is very crucial. Here we have a quick blurb from a Universal Laws of Engineering. Engineering is done with numbers. An analysis without numbers is only an opinion.
Great. Well, that finishes up our tech tips for today. We hope this webinar has been as informative and interesting as we believe, and we look forward to providing more information as we continue with the Tech Tips series. As always, we'd love to hear your comments, concerns, or questions, so please leave us a message either here on our website, www.prlresins.com, or on LinkedIn or our Facebook page. Thank you again for taking valuable time out of your day. We look forward to our next discussion. Stay safe and be well.